Hi guys, welcome back to the Autodesk Certified User Test 1 video walkthrough. So in the last video I stopped after going through objective 1, 2, and 3. So let's go ahead and continue with objective 4. Alright, so I stopped here. When you guys get to a certain point on some of these questions, go ahead and start closing the different files and saying, when it asks you to save, say no. So we're going to close these. No, no, no. And we end up back over here. Let me close this one as well. Okay, so the whole reason why we don't want to save anything is because we will use these files again in different questions, and if you save over the original file, then the answers that you get for your next question will be incorrect. Okay, so for objective 4, part modeling, let's go ahead and get started. Open sweep.ipt. So on this one, we see that we have a line, or a line and a circle. Let's read the question. Create a cross-section for a sweep feature using the spline provided as the path. The cross-section is a 0.25-inch diameter circle. Sweep the circle along the path. What is the new surface area of the sweep? Okay, so let's go ahead and see what we need to do. Okay, so creating sweeps is not very hard. We're just going to go up here to sweep, and sweep is just like extrude, except we're following a path instead of going in a straight line. And sometimes Inventor will see, oops, let me get this over here. Sometimes Inventor will see things for you automatically. Sometimes it won't. Sometimes it might look like this. So then you have to tell Inventor what to select. So it automatically sees our circle, and we have to select our curve that we want to follow. So we're going to click on this. And sometimes this works, and sometimes it doesn't. Sometimes it might need us to follow the path, or follow or create a fixed path. Either way, we're going to be clicking on this. Okay? So you should end up with something that looks like this. The question asks us, what is the new surface area of the sweep? .ipt. Okay, what I have shown you in previous problems is that you can right click on this and click on measure, and it'll tell you the surface area, 1.760. Unfortunately, this is the incorrect answer because it doesn't include the surface area of this circle or the surface area of this circle. So we need to get all of the area for the entire circle. Okay, so there's two ways of finding the surface area. We can go up here to our browser and click on sweep, right click on sweep and go to iProperties. And this is really large. Let me shrink this down a little bit to its normal size. Sorry guys. Okay, so when you get here, you're going to go to the physical tab, click on update, and it tells you the area, 1.859 cubic inches. And this is the correct answer. So that's one way of finding it. Or you can right click right here on the actual tab of sweep and go to iProperties, and then the same steps. Update, and here's the answer. 1.859, and we go back to this. 1.859 fits in the number of digits that we have available, and that's the correct answer. Okay, next question. Open pattern.ipt. So let's go back over here. Let me close this. And open pattern.ipt. Okay, so we have a pattern. Create a view representation of the current view. A view has already been created. Use the next default. What is the default name for this view? That's a lot of different information going on. Well, all we have to do is just rotate it until we create a new view. So we're just going to rotate this a little bit so we can get it to look similar. And we're going to go over here to our browser, right click on view 1 and click on new. What is the default new view? View 2. So view 2, one word, view number 2, and you're going to type that in. Pretty simple. Next question. Open rib.ipt. Open rib.ipt. All right, so here we have a box with a line. Create a rib from the sketch provided. Add the dimension for draft of 5 degrees. Keep all other default dimensions. What is the surface area of the rib? Okay, so creating ribs is not terribly difficult, but it's just something I've never taught you. So up here on the top, next to extrude, revolve, and all of these, we're going to go to rib. Inventor automatically sees it, and it wants us to keep everything defaulted except for the draft angle, which is going to be 5. Type that in, say OK. It wants to know what is the area, surface area of the rib. So just this blue part here, it wants to know what this is. So we're going to right click on this, go to measure. The answer is 10.822. So you type that in, 10.822. That is the correct answer. And let's move on. Open pattern.ipt. Create a circular pattern using the center hole as the axis of rotation. What is the distance between the centers of 2 adjacent holes? Okay, so here is why I tell you not to save over things, because you will use them again. So this is the one that we have to open up, pattern.ipt. It's already open. So all it wants us to do is to pattern this hole around the center axis. So we're going to go up here to pattern, click on circular pattern, choose the hole, and then the rotation axis is going to be the center, and we are going to pattern this 1, 2, 3, 4, 5, 6, 7, 8 times. So type in 8 and say OK. Next, it wants us to measure what is the distance between the center of 2 adjacent holes. So basically it can be any 2 holes. And we're going to right click on measure. Right click and go to measure. And we're just going to select this hole and this hole. And all the information is right here. From center to center, that is 73.093. 73.093, that's the answer. Let's move on. Okay. Open shell.ipt. Shell.ipt. Okay. So we just have an empty or just a solid box. Shell the part to 0.25 wall thickness. What is the area of the tiled surface? Okay. Shelling is something I haven't gone over with you, but it's a pretty simple concept. So up here next to hole and fillet, you'll find shell. Click on that, and we're going to remove this top face. So we just click on that, and it told us that the thickness is going to be 0.25 wall thickness. So we type that in, 0.25. It basically just cuts out everything on the inside while keeping the outside thickness 0.25. Just say OK, and there we have our shell. Now it wants to know what is the area of the tiled surface. I don't know why surface is put in twice, but it is. So we're just going to click right here, measure, area 9.625. 9.625 fits, that's the answer. Open Revolve. Create a model using the Revolve command and the geometry present. Reference the y-axis for the revolve. What is the surface area of the resultant model? Okay, so let's go ahead and open up Revolve. Okay, we have this funky looking pattern. We're going to go to Revolve, and our axis of rotation is going to be the y-axis. And we end up with something that looks like this. Say OK, and it gives us this. It doesn't come out silver, but it's fine. It wants to know what the surface area of what is the surface area of the resultant model. Well, it's kind of hard to just click right here and go to measure and tell us the area. Well, although that might be the correct answer, let's go ahead and go to I properties to find out. So we're going to go right click down here, go to I properties, physical, update, and yeah, it's the same information, 10.207. So sometimes by right clicking and measuring down here, you can get the answer, and sometimes you can click over here, go to I properties, and get the answer. It just depends on what it is that we're looking for. 10.207 is the correct answer, and let's move on. Open rectangular pattern.ipt. Okay. Create a rectangular pattern from the existing hole. Array the hole in a 5x3 pattern. Spacing is 1 inch. What is the surface area of the tiled surface? Okay. So we're going to go to rectangular pattern, something I don't think I've really covered very much with you guys. So we're going to click on rectangular pattern. Hole 1 is our feature. Direction 1, we're going to click right here, and we want to go this way, up. So I'm going to flip my direction and type in 5. Spacing is 1 inch. Direction 2, I'm going to type in 3. Spacing is 1 inch. Say OK. Right click on the surface, go to measure. The total area is 39.264. 39.264 fits, and that is the correct answer. Open holes.ipt. Holes. Okay, so we have it open. Change the small hole of the plate to counterbore. Make counterbore 1 inch diameter and 0.125 deep. What is the surface area of the plate? So here is where knowing a little bit more about Inventor helps you. So it wants us to make a counterbore and then to add a depth. Well, the counterbore has nothing to do with the surface area, so all we have to do is change the size of this hole to 1 inch diameter, and we'd still get the same answer. So hole 2, or hole 1 is the big one, hole 2 is the small one. All I have to do is change the size of the hole to 1 and find the surface area. Click on measure. The surface area is 44.073. 44.073 fits, and that is the correct answer. Open shell.ipt. Okay, we had shell open, so I'm going to go ahead and start closing these different things and saying no, I don't want to save. Okay, so open shell.ipt. Okay. Chamfer all 4 corners to 0.5. Create a shell with a 0.125 wall thickness. Remove the top face. What is the surface area of the inside chamfer? Okay, so we have to go ahead and chamfer. So I'm going to select all, let me move this over here. I'm going to select all of our vertical surfaces, change the distance to 0.5, and click apply. And then I'm going to shell this to be 0.125 on my thickness and say OK. And it wants to know what is the surface area of this corner. So I'm going to click there, go to measure. The area is 1.132. Does that fit? 1.132. That is the correct answer. Let's move on. Open extrude surface. Create the surface model using the sketch provided. Extrude to a depth of 4 inches. What is the surface area? Okay, so extrude surface. Let's go ahead and find that. Okay, well, we just have a line. Let's see if we can go ahead and extrude it. Well, it selected it. So we're going to say 4 inches. And it wants to know what is the surface area. So we can right click on it, go to measure, and the area is 15.325. But let's double check and check its eye properties. Physical, update, and there's nothing there because there wasn't anything solid, it was just a line. So we're going to go with 15.325 as the answer. 15.325 fits, and that's the correct answer. Let's move on. What tool would be used to apply the rounded corner as shown? So we have straight 90-degree corners, and we want to turn them into rounded corners. What would we use? Fillet, chamfer, smooth, or bevel? Well, I've only really ever gone over fillets with you guys, and fillets, you know, round off corners, so the answer is fillet. Objective number 5, sketching. Open Viewcube.ipt. Use the Viewcube to see the other side of the part. What is the length of the longest line? Okay, so open Viewcube. Alright, we don't see anything on this, but if we turn it around, we see that we have this here. What is the length of the longest line? Well, which is the longest line? This one right here. We can right click on that line, click on measure, and it tells us that it's 166 inches long. So this is a very big object. Go over here. It just needs 3 digits. 166 is the correct answer. Open workfeature.ipt. Work feature. Last thing in there. Okay. Create the bridge in the part as shown. Use the sketch shown in the view. Create the bridge on a work plane 2 inches down inside the box from the opening. The extrusion depth is 0.25. What is the surface area of the tiled area? Okay, there's a lot of steps to this, but it's not going to be too difficult. So it's first asking us to create a offset plane. So we're going to create a new plane by going to the pull down menu of plane. Go to offset from plane, and we want to make a plane that goes in 2. Well, if I type in 2, it comes out. So I have to type in -2, and it goes in. Okay, once I have this, I'm going to go ahead and click on create a sketch on that plane. And all I need to do is project the geometry so that way I know what I'm working with, and then create a rectangle. So we look at the actual object. It's 3 inches from the front to the bottom of it, and it's 0.5 wide. Okay, so from the bottom of the object to the bottom of our rectangle, it's 3 inches, and this is 0.5. Okay, finish my sketch. I'm going to go ahead and extrude this. It did say to extrude it 0.25. Okay, And then what is the surface area of the tiled area? So just of this top portion of the bridge that we made, what is that surface area? We're going to right click on that surface area, go to measure, and that surface area is 2.75. So go back over here, 2.75 inches squared, that fits. Cool, let's move on. This one is a little bit difficult and will cause you some issues because there's a lot of information to look up. So open parameters.ipt. So parameters.ipt. Okay. So, let's see. Let me double check and see where parameters are because I don't even remember. Is it right here? There they are. Okay. So the question asks us, change the diameter of the master hole to 8.165. What is the parameter name of the master hole? Well, that's a lot of information that is not given to us. So right here it tells us what to do. In order to change the diameter of the master hole, you have to first identify it. The master hole is the hole that provides the data for the circular pattern. Go to the browser and look for the hole object before the circular pattern. Let the mouse rest on the hole object icon in the browser. The master hole will be highlighted in the part. To change the diameter, double-click on the hole in the browser. Change the master hole diameter to 8.1657. Select OK to end the command. Okay, so we just have to go, we have our circular pattern, we go to the hole before it, right click, double click, and change the master hole to 8.1 something something something, 8.1657, 8.1657, say OK. All right. What is the parameter name of the master hole? Well, the easiest thing to say is to look over here and say, oh, it's hole 1. Well, yeah, it would be, but unfortunately, no. Go to the Manage tab, Parameters panel, Parameters command. Find the parameter for the hole that reads 8.1657. The parameter number is D14. So we go to the Manage tab, find parameters, which is right here, and it brings up this giant dialog box. Okay, it has a whole bunch of information that is like, what? Okay, so we're going to look down here at the equation and find 8.1657. Here it is. The parameter name, or consumed by hole 1, the parameter name is D14. That is the correct answer. It's a lot of steps to find a simple thing. D14. Let's move on. What type of dimension controls geometry? Well, this is something that we can figure out without really having to open up dim types. So if we are going to control geometry, there are two different types of dimensions, driven and driving. So think about it. If you are driving a car, you control the car, and everyone in the car is basically being taken by you. So you are in control. If you are driven, you're basically a passenger in that car. You have no control over where that car is going. So, what type of dimension controls geometry? If we are going to control the geometry, we want to be driving that geometry. We want to be using a driving dimension because that geometry is going to be controlling everything else. So it's going to be a driving dimension. I know this is a little bit hard to understand, but we'll go over it later, or maybe not. Next question. Open shared sketches.ipt. Okay, so let's go to shared sketches. Okay. The question reads, share the sketch for the circular cutout. Use the sketch to complete the part shown. What is the surface area of the tiled surface? So we're going to use the circular cutout right here for this one and put it back here. There's several different ways of doing this. The easiest way to do it is just by projecting geometry. We can copy and paste a sketch, or we can share a sketch. But given the question, it's easiest to do it by projecting geometry. So go ahead and click on this surface. Click on Create Sketch. And all we're going to do is project this geometry here. Once we do that, we're going to finish the sketch. And we're going to click on Extrude. And then we're going to cut out what was being asked, and I'm going to change our distance from whatever it is here, and I'm going to change it to this button right here that says 2, and choose this surface. Okay? It asks us, what is the surface area of the tiled surface? So basically all we had to do is click right here, go to Measure, and here is the area. 2.721 inches squared, 2.721 inches squared. Let's move on. Open sketch constraints. Sketch constraints right here. Okay. So here is where following directions is very important. Starting at the top and moving clockwise, apply horizontal or vertical constraints to all sides. Dimension the rectangle. What is the length of the left vertical line? Round to 3 decimal places. Okay, so we're going to double click into sketch 1 and use our vertical and our horizontal constraints. So starting with this one and moving clockwise, okay, we're going to create or find the answer. So click on horizontal, click on this line. Click on vertical, click on this line. Horizontal, oops, let me try that again. This line, vertical, this line. Then it wants to know what is the dimension, round to 3 decimal places. So 1.137. That is the correct answer. 1.137 fits. Let's move on. So the reason why you work and follow directions by going clockwise is because if you chose top and bottom, horizontal, left and right, vertical, it wouldn't give you that answer. Next question. Objective 6. We have a few more questions and then we'll be done. Browser editing. True or false? A sketch cannot be used again after it has been consumed. Can we use a sketch again after we use it? Let's look at Inventor. So, if we go to this one, and we see that we have all these different extrusions, we know that sketch 7 was consumed by extrusion 7. But we can right click on that sketch and we can share the sketch, or we can copy the sketch and use it again on additional sketches. So the answer to this is a sketch cannot be used again after it has been consumed. I believe the answer is false. A sketch can be used again. So I believe it's false, but I will double check later. Okay. True or false? A feature that has dependent features cannot be suppressed. So let's go to Inventor to see what's going on. If we have a feature like, let's say this one. We have a feature, the hole, and we have dependent features, the circular pattern. Can we suppress it? Yes or no? A feature that has dependent features cannot be suppressed. So feature, if we click on hole 1, and right click on it and go to suppress features, can it be suppressed? Yes or no? So if I click on it, what happens? Oh, those holes are gone. So yes, it can be suppressed. Let's unsuppress it, bring it back, and all of the holes come back. So yes. True or false? A feature that has dependent features cannot be suppressed. False. It can be suppressed. How are suppressed features indicated in the model viewer? Okay, let's go to Inventor. Let's suppress our hole number 1. If we suppress our feature, what does it look like? It's grayed out with a line through it, and it says suppressed. So, the feature is grayed out. Yes. The feature is grayed out with a line through it. Yes. Suppressed features do not appear in the model viewer. Well, yeah, but they're there. Like, so they are there. The feature has an exclamation mark next to it. No. So the answer is the feature is grayed out with a line through it. So like this one right here, suppressed features do not appear. No, they don't disappear. They're still there. They're just there, grayed out with a line through it. So if you need any answers, I have those answers available for you at my desk, or you can go ahead and look for those answers in the PowerPoint later. So hopefully this helped. It gave you an insight of what the ACU Inventor test will be asking you. I know that this was a lot of information and a lot of different things that you really didn't have any experience with. Hopefully you guys understood it and can move forward. What I would like you guys to do next is to attempt to take this test on your own and see how you do. See if you can find the information the way that I showed you. And if you can't, that's okay. I am here to help you whenever you need it. So thank you guys for sitting through this. I know this was a little bit difficult, but I hope you guys enjoyed it and that you guys learned a lot. I'll see you in the next video. Bye.